Okay, good evening. This is Professor David J. Telos Reyes. My topic for this session will be a long video format discussion. This is a random topic. This will be an additional topic under my channel, and this falls under analytic geometry. So we are solving a problem under analytic geometry. This is analytic geometry, and we are given a problem. What is the distance between the points 3 points with the coordinates 3 and 4. The second point is the coordinates are actually 9 and minus 3. In the xy plane, meaning in the Cartesian coordinate system. And additional requirement is find also the slope. Okay. So actually we are given point number 1. Let's try to bring out the given. Capital letter P with the subscript 1 meaning point number 1. Coordinates 3 and 4. Capital letter P with the subscript 2 meaning point number 2. The coordinates is 9 and minus 3. The problem is asking what will be the distance between these 2 points here. And additional requirement, what will be m? M is actually slope. Small letter d represents the distance between the 2 points. Okay, it is this. And the other requirement is what will be the slope. This is the line connecting points number 1 and number 2. And the problem is asking also for the slope. So from the figure alone, we could see that the slope is actually upwards to the left. So it should be a negative slope. Okay, let's try to bring out the solution. To bring out the solution, we'll try to figure out first. So this will be the y-axis, x-axis. Point number 1 is this one here with the coordinates 3 and 4. This is 1, 2, 3. The abscissa is 3. And the ordinate is 4. This is 1, 2, 3, 4 units. This is 4 units. This is 3 units. So the intersection of the abscissa and the ordinate represents the location of point number 1. And the coordinates is 3 and 4. Point number 2. The abscissa is 9. So we will count abscissa along the x-axis 9 units. So this 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 with respect to the y-axis, right? And the ordinate is actually negative 3. Negative, so it is below the x-axis. So we will count 3 units below this 1, 2, 3. This is actually negative 3. So the intersection of this horizontal line and vertical line represents the second point. It is actually with the coordinates 9 and minus 3, meaning the abscissa is 9 units and the ordinate is 3 units, but it's negative because it's below the x-axis. So the coordinates is actually 9 and minus 3. So if we try to project a vertical line and a horizontal line, okay, actually we could compute for this distance here. I represented this distance here will be an x2 minus x1. It should be the abscissa of this point here minus the abscissa of point number 1. So I place it here, it's x2 minus x1. And for this height here, it is actually the difference in the ordinates. And I place it as simply the ordinate of this one minus the ordinate of the second one. So I place it here, this is y sub 2 minus y sub 1. This is a vertical line, this is a horizontal line. So if this is vertical and horizontal, this should be a 90-degree angle. If we try to connect the 2 points, okay, that is now the distance d. And the problem is asking for this distance here. So this is an easy matter now, because it seems we are given the right triangle and we are given the adjacent side in the opposite side, and the problem is only asking for the hypotenuse. So to compute for D, we use Pythagoras principle. The square of this plus the square of this should be equal to the square of D. And solving for D, it's the hypotenuse, right? It should be x of 2 minus x of 1 quantity square plus y sub 2 minus y sub 1 quantity square. And this is the so-called, distance formula. This is the first equation under analytic geometry, the distance between 2 points. It will be the difference in abscissas quantity square, the difference in the obtuse quantity square, then take the square root, that will be the distance. So we are using our knowledge on the study or the concepts of trigonometry, that is properties of right triangle. We are given this side here, we are given this side, so we will compute for the distance D by using Pythagoras principle. So this should be 9 minus 3 quantity square. X of 2 is 9, x of 1 is 3, okay? Y sub 2 is negative 3, the ordinate here. And y sub 1 is actually positive 4, but the operation is subtraction, right? So this is minus 4 quantity square. 9 minus 3 is 6. 6 squared is 36. Minus 3 minus 4. Actually, they add up, they are both negative, right? So this should be, but it will be negative 7, and if we try to square it, okay, that will be 49. So 36 plus 49 will be 85. So the distance between these is actually the square root of 85. That's almost, where's my calculator? 85 square root. Come on, 85 square root. 9.21 units. Because 9 square is 81, this is 85. Okay, so it's greater than 9. Okay. For the angle, for the slope of this line here, we are expecting a negative slope, meaning a slope that falls on the second quadrant. Okay. If we try to bring out the compute for the slope, this is, we represent this as alpha. This is y2 minus y1. This is x2 minus x1. This is a right angle. So if we try to take the tangent of alpha, okay, which is actually by definition under the study of analytic geometry to be equal to slope, m now is equal tangent of alpha will be y2 minus y1 over x2 minus x1. If we try to take the tangent of this, should be opposite over adjacent. Okay, and that is actually, this is actually the second formula under the study of analytic geometry. The formula on how to compute for the slope of a straight line. It will be the difference in y2 minus y1 over x2 minus x1. You can interchange this one. It could be y1 minus y2 or x1 minus x2. It doesn't matter. But this is the general formula. So if we try to compute for the slope, the slope now will be a direct substitution one. Minus y sub 2 is a negative 3, right? It refers to point 2. The subscript 2 refers to this point here. The ordinate here is negative 3, so this is negative 3. Minus, the ordinate here is 4, but the operation is subtraction, so this is minus 4. All over. x2 is actually 9, positive 9, right? So this is 9. Minus, the operation is subtraction. x1 is actually positive 3, so this is minus 3. Minus 3 minus 4 is minus 7. 9 minus 3 is 6. And the slope is actually negative 7 over 6. Okay, and I place it here, slope upwards to the left. If we try to compute the angle here, 7 divided by 6 equals second function tangent. Okay, plus 90 degrees. Oh, this is 139.4 degrees. 139.4 degrees. If we try to specify the angle with respect to the 0 degree, it will be this. And this value here is actually 100, is it correct? 7 divided by 6 equals second function tangent minus plus 180. Oh, 130.60. It should be 130.60 degrees. Okay. This is 130, almost 131 degrees. Okay. 131 is greater than 90 degrees. Like what I said, it falls under the second quadrant. It falls under the second quadrant. Right? It will be something like this. If we try to transfer this one on the origin, this is 131 degrees. Slope upwards to the left. Okay, that's it, guys. That's the proper way on how to compute for the distance d, okay, and the slope for a given straight line if we are given 2 points. Okay, good evening from Los Angeles. Professor David Jadelso.